Hey, this is Mr. James. In this video, we're going to be talking about the vocabulary and features of functions and graphs. We're going to spend most of our time talking about graphs and labeling them, minimums, maximums, different parts of curves, things like that. And so it's going to be a really good idea for you to have at least 6 different colors of markers, pens, pencils, whatever. But 6 different colors would be fantastic because when we label things, it's going to be very, very helpful for you and to look back in your notes if everything is kind of color-coded. So if you need to, pause the video now and grab 6 different markers, pens, pencils, whatever you've got. Before we get to the graphs, though, we're going to start talking about algebraic representations just for a second. So with those different colors that you've got, I'd like you to underline each term you see in this algebraic function right here. I'd like you to circle every variable in a different color. I'll use red. And I'd like you to also circle every coefficient you see in another color. I'll use yellow. So pause the video now and try and do that. Underline the terms, circle the variables, and circle the coefficients in different color with this function. The answers will be up on the screen in 3, 2, make sure you've paused because here they come, 1. And here we are. So I've got everything labeled here, and I've also put some definitions here that we can talk about. So a term are numbers and variables multiplied together, separated by addition or subtraction. So each of these, so we get 1, 2, 3, 4, we've got 5 terms in this function right here, all underlined each separately in blue. And they're separated by addition or subtraction. A variable is a varying unknown quantity. So you can see in red I've put these x's are our variables here. But you'll also notice in this last term right here I've put x to the 0th as a variable. Even though there's no variable here, x to the 0 is 1. We'll talk about that later in the year. But there still could be a variable kind of on the end of this, even though 1 is not written. Lastly, a coefficient is a number multiplied by a variable. So you can see we've got these coefficients here, 2, 3, and this term doesn't seem to have a coefficient, but we can always put the number 1 in front of the variable because 1 times that variable is just the variable. So our coefficient is technically 1, and the same thing here, it's also 1, even though it is not written. Now let's move on to graphing functions in general. This year we're going to deal with all sorts of crazy functions. Functions that repeat, functions that go off to infinity, functions that come down to a certain number, functions that don't exist at certain values, all sorts of things. But this is the most important thing to remember for all functions. When you don't remember how to graph a function, well, all else fails, you can always draw a table and plot points to get a general idea of what the graph of that function looks like, even if you don't remember all of these things we're going to learn this year. So you can always rely on this. So here's what I mean by drawing a table and plotting points. I'll make a table. Here's x, my inputs. Here's f of x, my outputs. For this function right here, f of x equals x squared divided by 4 minus 5. So what I'm going to do is just put a few numbers in here for x. These are some good numbers to try. -4, -2, 0, 2, and 4. So I get some points all throughout the graph. And then take these numbers as inputs and put them into this function and see what you get as outputs. And then graph those and connect the points to see if you can create a smooth curve. Pause the video now and see if you can do that by yourself. Put these numbers into the function x squared divided by 4 minus 5 and then graph them. The answers will be coming up in 3, 2, make sure you paused. Here they are. Alright, so here's the finished table right here, and I've graphed those points on my graph, and I get this kind of curve right here. You might recognize this as a parabola. Now, like I said, this year we'll learn some shortcuts on how to graph the parabola, how it looks, why it looks that way. But if all else fails, you can just plug some points in and draw a rough sketch of the curve this way. Let's try the same thing for this next one. Again, I'll make a quick table of x, and this time we don't have f of x, we have g of x is 1 over x. So g of x, my output. Okay, and let's see, for this one, let's try putting in the values. Let's try -5. Let's try -1. I'm going to put in -0.5, 0, 0.5, +1, and +5 right there. So now see if you can go ahead and fill in what the values here would be, and then go ahead and graph them. Just to give you an example, -5 would go in here and be 1 over -5, or -1/5. Go ahead and see if you can figure out what the rest of these outputs would be for g of x, and then graph your function over here. The answers will be coming up on the screen in 3, 2, make sure to pause. And so here's my graph. One cool thing to note here, that when I put 1/2 into this function, that's 1 divided by 1/2. And remember, dividing by a fraction is the same as multiplying by a reciprocal, or that flipped fraction. So it's kind of like multiplying by 2 over 1, which is just 2. Another quick thing to note, that when I have 1 over 0, dividing by 0 is undefined, remember. So I can't actually graph that on my graph. But if I plot the points that I do have, I kind of get this kind of two-curve kind of picture. It's a little bit weird, and we'll talk about this later in the year as to why this happens. But for now, just remember, when all else fails, and you don't remember anything else about a function, you can always draw a table and plot some points to get a rough sketch. That ends part 1. Please make sure you watch part 2 of vocabulary and features of functions and graphs.